All right, before we start looking at graphing rational functions, I want to quickly review a couple of the concepts we've been going over um, within domain. So there's two things we've been looking at within domain. We've been looking at removable holes and vertical asymptotes. So for something to be a hole, denominator must cancel with numerator. So remember, if there's part that we can factor out, then we can call it a hole there. A vertical asymptote is when denominator equals 0. Okay, so let's take a look at these examples. For the first example, okay, we want to see what we can factor out. There's nothing on the top we can factor out, but we can rewrite the bottom as, let's see, I can take out a 2x, leaving me with an x minus 4. So this goes back to the removable holes. We can remove these by canceling them, meaning that we would have a hole when x equals 4. Okay, but we also have a vertical asymptote when 2x equals 0, when x equals 0. So we have a vertical asymptote at x equals 0 and a hole at x equals 4. In our second one, as we look through it, we could probably factor the top, but I don't think we need to, because if you look at the denominator, okay, there's never a time when this will equal 0, because x squared will equal -4, and that doesn't matter. So nothing cancels, nothing is set equal to 0. So our domain is all real numbers. Okay, so every single value we put in there will work. All right, for our last one, okay, nothing cancels at the top, but we need to find out when x plus 1 equals 0, which is when x equals -1. So we know we have a vertical asymptote at x equals -1, meaning our domain is all reals, except for x does not equal -1. So that's just a quick review of finding the domain, reviewing holes and vertical asymptotes of rational functions.